Yep.
Yeah.
All right. Hi, my name is Lucas, and my project is developing a machine learning equipped drone for early detection of wildfires in forests around the Bay Area. So right now, wildfires severely impact lives and life worldwide. In 2018, California's wildfires caused basically $150 billion in economic damage, which is a lot. And like I said, wildfires, they displace individuals, destroy homes. And right now, fire hazard warnings help raise awareness, but they're not quick enough, and people aren't warned fast enough. So our solution is to build a machine learning model which automates wildfire risk assessment in real time using a drone and a temperature sensor. And it only requires three inputs right now: temperature, humidity, and aerial photo. So right now there are some models, like there are some wildfire risk index maps, but they don't use machine learning or AI generated data. So our AI-powered solution aims to detect wildfire risk even before the fires start, just using the real-time data. Our model leverages machine learning and AI to provide accessible and user-friendly wildfire risk assessment tools for everybody, basically. Um, so our goal is to develop a specialized wildfire prediction model, and we plan to do that with a lot of data collection, making a user-friendly interface and instant assessment. This can help a diverse user base with a proactive approach, and our accuracy goals to aim about over 90%. So for data collection, we started with over 5,000 pieces of data, which each entry includes a satellite image, daily temperature, and humidity at the time. For the satellite images, we use Google Earth Pro, and we use timeanddate.com and wonderground.com for the temperature and humidity data. For the machine learning For the machine learning model, we used the TensorFlow library for building and training the models using an MLP for temperature and humidity patterns and a CNN for analyzing the satellite images of the vegetation. So here's like a piece of the code. It's really long. So like I said, we used 5,750 data points with 100 epochs with batch sizes of 32 because we found that 100 epochs was the most optimal amount. And we achieved an accuracy of around 92%. We used Ophelia Go and Sensor Push. These are the two other apps that we used for the temperature, humidity, and the drone. So we collected basically 445 data points, each including an image of vegetation and temperature and humidity values. And we found that, as you can see in the graph, the higher the temperature and the lower the humidity, the higher chances of a wildfire actually occurring in the area. So here is the accuracy of our data. We have a 92% accuracy rate, and it will grow higher as we add more data. We use the US Department of Homeland Security map to validate the accuracy of our model. In the graph on the left, you can see on the first two graphs, the false positives are really, really little, which shows the high accuracy rate of our model. So another thing that we created was a risk index map. So on the left is a photo of the US Department of Homeland Security map, which shows the risk index of a wildfire. And on the right is ours of the Bay Area. As you can see, ours is more precise and pristine, and it gets updated automatically as well for every use of the drone. Another thing that we created was a website using Wix to provide global access to our tool. So users will input the temperature and humidity values, while the aerial image will automatically be inputted as long as you connect the drone to the website. The website will display a risk index from 0 to 100 to evaluate the wildfire risk, with 75 to 100 means that it is pretty prone to wildfires. So here are some real world examples that we collected, each with the temperature, humidity, aerial photo, and outputting the risk index. So this AI-driven model, it integrates image data and environmental variables to provide a comprehensive wildfire risk assessment, and it highlights the power of AI in enhancing predictive accuracy. So in the future, we obviously plan to add more. So first of all, the accuracy, we want to make it to as close to 100% as possible. So we try to do that by increasing more training data and model configuration. We also want to automate the temperature and humidity values, not only the aerial photo, but also the temperature and humidity data points too. Also, we want to incorporate more features like elevation, wind speed. All of these are also very crucial for wildfire risk. Here's a photo of us flying the drone. We envision a world where AI-driven solutions are the forefront of disaster prevention. Thank you for your attention and support. Let's work together to turn this vision into a reality. Thank you. Any questions?